Hello, everyone. This is Colleen Milton, and on behalf of BigPanda and 451 Research, I would like to welcome you and say thanks for attending today's webcast titled, Do Legacy Root Cause Analysis Techniques Still Work for Modern Fast-Moving IT? Leading off the discussion today will be Nancy Gohring, who's a Senior Analyst in Application and Infrastructure Performance at 451 Research. Following Nancy will be Elik Eizenberg, who is CTO at BigPanda. Just a few quick housekeeping items before we get started. To ask a question, simply type it in the question box on your screen, and we'll get to as many as we can. The presentation slides are available for download in the resources section on your screen. And finally, please check back for the on-demand version of this webinar after the conclusion of the live event. And with that, I'll turn it over to Nancy.
Great. Thank you so much, Colleen. Thanks to BigPanda for inviting me, and thanks everyone for joining today. So I'm going to start out by talking about some big picture trends in the market around technology adoption in IT. And talk a little bit about the impact that that can have on your approach to troubleshooting and monitoring, particularly if you're using legacy tools and approaches. And then I'll touch on a couple of recommendations if you are struggling with using those more traditional approaches in a more modern environment. So from a really big picture perspective, we're continuing to see adoption of DevOps and DevOps practices in organizations of all sizes and all kinds. And when I talk to organizations about why they're adopting DevOps practices, the two top things people typically talk about are speed, so the ability to move faster, and also a hope of improving collaboration between teams and also individuals with specialties within an organization. So this was a recent study we did where we asked organizations why they're adopting DevOps, and you can see the top answer here was flexibility to quickly respond to changes. Faster software releases was the third top most frequently cited response. You see enhances teamwork shows up there. So this really backs up what I'm hearing anecdotally when I talk to people. And it turns out DevOps actually really is helpful in terms of speeding up release cadence. So here we asked people how broadly they were implementing DevOps in their organization, and then we asked about the frequency of their software releases. And it's really interesting. You can see here that the more broadly deployed DevOps is within an organization, the more likely they are to be releasing quickly. So amongst those who said that they're releasing hourly, almost all of them have full adoption of DevOps in their organization. With daily software releases, it's also the majority of people have fully deployed DevOps in their organization. So it's clearly working. And you know, in order to get there, in order to move faster, along with DevOps, organizations are adopting a whole bunch of new technologies. So things like microservices, this approach, this architecture is really helping organizations more quickly drive software updates and software releases. Containers are similarly being adopted for that reason. But what becomes interesting is when you see organizations that are embracing DevOps practices and are adopting some of these cloud-native technologies is the operations, monitoring, troubleshooting becomes much more complex because these environments are a lot more complex than they used to be, and they're much more dynamic. So things change quite a lot more frequently than they used to. So it's not just software updates themselves, but containers might be coming and going. If you're adopting serverless environments, there's a really fast rate of change. So let me just give you a sort of a snapshot of what that change can look like in some organizations. So let's look at Google. Now this is, obviously they're a bit of an outlier because they're enormous, one of the biggest web operations out there. But still, it's really interesting when you start to think about this. So they launch 4 billion containers every week, and that amounts to 6,600 containers a second, which is a little bit mind-boggling when you think about it. And it's, you know, again, Google is really big, but this begins to get you thinking about the rate of change, right? So each of these containers is spinning up and spinning down, and it's operating for some amount of time during which presumably Google's collecting some type of operations data. And it's not just Google, so here's a whole bunch of other organizations. Again, these are also large operations, but it sort of helps hit home the rate of change that's going on in modern cloud-native complex environments. So these are all stats that I collected at various conferences, Monorama last year, also Datadog Dash this year. So you've got companies like Hulu. They have 1,000 microservices that are written and managed by 100 different teams. And at peak times, Hulu has the potential to collect 147 million logs every minute. And you can see some of these other examples here, right? Uber has somewhere around 4,000 microservices. I once saw someone from Uber present at a conference, and he said they stopped counting because it didn't really make a difference, right? I mean, who really cares if it's 4,000 or 3,000 or 5,000? At that point, you know, it's complex, it's dynamic, it's moving. You need some new tools and some new approaches to keeping an eye on that. And that's hard to come by. So when we do our surveys, we do a series of interviews, like live interviews with people. And I thought this quote I thought was really interesting. So this is someone who works for a pretty large financial services business with 100,000 plus employees. And this person said, you know, managing microservices at scale is really hard. The biggest gap is there's not a lot of people with microservices types of skills that you can readily hire. It's about running an approach to develop apps in the context of large apps. When you get to hundreds and thousands of services, how do you run those? How do you scale that? So this is a skill that's not out there. It's something that I think a lot of organizations are struggling with. They're trying to learn from some of those early cloud native types like the Hulus of the world and Google, because this is all very new, it's very complicated, it's very dynamic, and it's the sort of traditional approaches tend to not work as well in these environments. And I'll just note against this backdrop, performance is potentially more important than ever before. So this was a study that we did. It was a survey of consumers, of end users, and we asked them how likely they were to switch brand or provider due to poor performance. So if their software, their app was buggy or slow or just otherwise performed poorly, how likely were they to switch? And 79% of people said very likely or somewhat likely to switch. So the stakes are pretty high here to ensure that applications are performing well. So let me talk just a little bit about why the old approaches to monitoring and troubleshooting and performance don't work in these modern environments. So one of the top reasons is that organizations tend to have traditionally used siloed monitoring tools. So these are tools that maybe look after infrastructure. They have a separate tool that looks after custom applications. They might have another tool that looks at database monitoring. You might have a network performance monitoring tool. And each of those tools keeps the data that they collect in a silo. And there's no way to understand the relationship between performance problems in those different stacks. So you're not able to see dependencies. And certainly when you get into a microservices architecture, that challenge is magnified, right? So not only do you not understand how different layers of the stack are related, you also very often will have trouble understanding how the performance of one microservice might impact the performance of another microservice. You also, and on a related note, tend to have a lack of collaboration across teams, and this sometimes happens because of those siloed tools. So sometimes you have a team of network admins that use one tool. You have another team who's responsible for infrastructure that uses one tool. You've got another team that's using an APM tool. And since they're all looking at these different silos of data, they have trouble working together because the data they're looking at depicts a different story. Usually in these in a more traditional monitoring environment, you're unable to see the relationship between change in the environment and problems that are occurring. So you don't know that a recent code push just happened, and perhaps that's the cause of a performance problem. And, also on a related note, a lot of organizations have invested pretty heavily in CMDBs, but they're certainly recognizing that CMDBs are not designed to track change at the cadence that it's happening in a cloud-native environment. And then the final point I'll make in terms of old approaches and challenges that people have with them is that organizational models often leave gaps in coverage. And, that's one reason I thought that microservices quote was so interesting, because one thing I really commonly see happen, particularly with the adoption of microservices and DevOps, is very often an organization will create these DevOps groups that are responsible for one or more microservice, but there's no one who's designated to look at the overall performance of an application. So it may look like all the microservices are operating perfectly, but the user experience is poor, and there's no one whose job it is really to keep an eye on that, on the overall user experience. And so that's just one example of a problem that I see popping up sometimes in a traditional or even a sort of a maturing organizational model where a business has adopted DevOps but maybe retains an IT ops group, and it's not really clear who's doing what or who's responsible for the overall user experience. So if any of this sounds familiar, I'm going to throw out some recommendations for some things you can do to try to solve some of the problems and address, make some changes to these approaches that can help you if you're in a more modern environment. So one is simply unify the operations data that you're collecting across your environment. And there's different ways that you can do this. Some people end up designating a tool as being a centralized spot where they send certain types of operations data where they can correlate it and get a better understanding of dependencies across their environment. So there's a number of different approaches that you can take, but it's a good idea to sit down, take a look at your monitoring tools, your monitoring environment, and think about ways that you can break down those silos between tools. And doing that will help you get insight into dependencies and also topology. So particularly in more complex environments that are changing frequently, being able to see the topology is really helpful. So in a traditional environment, you may have had sort of a mental model where you knew what your topology looked like off the top of your head, but in a complex, dynamic environment, that's much harder to do. It's going to be harder for you to know off the top of your head what dependencies look like, what your topology looks like. You're going to want to be able to relate changes to anomalies or problems. So again, if you're pushing code more frequently, if you're moving, if you've got containers spinning up and down frequently, if you're in one of these modern environments that's changing more frequently, you need to understand when a recent change may be the cause of an ongoing problem. You're going to want to employ advanced analytics tools probably, and that's in part because the volume of data that you're going to be collecting is going to grow. So, if you think about the Googles of the world launching billions of containers every week, that's a lot of data to manage, and, humans can't just analyze that visually anymore. So there's a lot of tools these days that are employing various kinds of analytics that can help you pull intelligence out of this growing volume of IT operations data. And automation is increasingly in the spotlight again these days. And I think there's a number of interesting drivers for that. One of them is that we hear from people in our surveys and also anecdotally who say that the amount of work they're being asked to do is growing, and yet their teams are not growing. So, and part of that is related to the growing complexity of these environments. There's so many moving parts. It's just difficult to track it in the way that people have been accustomed to traditionally. And so a lot of organizations are taking interest in automation as a way to, at the very least, take the burden of some rote tasks off of team members. But, you know, ideally, do more than that and really free up your team's time to work on, you know, important projects that can really drive the business forward. And then finally, think about your organizational models. So, you know, I alluded to this earlier, some struggles that I hear some organizations face, particularly when they begin to embrace DevOps more broadly. You know, and one thing to think about is I've seen a lot of organizations meet success by sort of evolving their IT operations team into something that resembles an observability team, and otherwise just a centralized team that becomes the expert in monitoring tools and can serve as a resource to DevOps teams. So in essence, offer monitoring tools as a service to DevOps teams. DevOps teams are still using those tools to monitor their microservices and address performance problems, but this centralized team can help out with really difficult or challenging problems and also manage the tool set, which can really take some work off of the DevOps teams. So those are a number of ideas for things that you can do if you're suffering from some of these challenges. And then there's just one point that I want to leave you with before I hand off, and I'm going to flash a couple of slides here, but something that's really interesting is, you know, I've been talking here today about cloud-native environments as if, you know, they're wholly to blame for problems and challenges that operations teams may be facing. But it's interesting, it turns out that the organizations that we talk to also suffer from challenges related to legacy environments. And given that our research shows that most organizations expect to be hybrid for many years to come, I think it's important to think about legacy workloads as well and hybrid environments. So it's not just the cloud native environments that can benefit from some of these new approaches to troubleshooting and monitoring. It's all the environments that you might have in your organization. So this is one data point that I thought was interesting. So we asked organizations what barriers they face to improving customer experience, and the third answer from the top at 27% was complexity of existing legacy applications. So I thought that was interesting, again, sort of pointing to the fact that legacy environments also have some challenges. And then this was a survey that we did. This was specifically targeted to storage professionals. And so we asked them about the challenges, some challenges that they faced in terms of adopting IT automation. And again, the third answer from the top was uncontrolled change management. So again, these were respondents who are responsible in part for more traditional environments. These are folks who are tasked with looking after storage for their organizations, and they said uncontrolled change management was a challenge that they were facing as they're trying to adopt IT automation. So this idea of change in a rapidly changing environment and the impact that can have on operations organizations spans both legacy and cloud native environments. So with that, I will hand over to Elik.
Thank you, Nancy. I'm going to continue with the same thread around the acceleration of IT and the challenges that it creates for modern operations teams. But I'm going to focus around specific practices around topology information and around change management and continuous delivery. And hopefully I can show you today a few recommendations around strategies that will help you tackle those challenges that Nancy discussed and I'm going to cover as well. So let's start with kind of this more high-level view of what's happening in the world of IT around this rapid acceleration We know that in the world of infrastructure management, right, the main theme is definitely the adoption of cloud, but also we're seeing a lot of rapid adoption of containers and Kubernetes-based orchestration. Frankly, this has created a couple of orders of magnitude increase in the velocity of change for infrastructure, right? This is not a 10% increase in velocity or a 20% increase. This is a few orders of magnitude faster than it used to be. If it took you 3 months to get a server deployed in your data center, in the rack, all the networks wired, the operating system installed, today you can get a new instance, a new server in the cloud within a few seconds, essentially. And when we look at the software world, that has also accelerated very rapidly. And most recently, you know, it all started maybe 15 years ago with the whole agile development movement and having shorter cycles. But in the last 5 years or so, most enterprises are embracing the world of microservices, which means that when you just push it immediately to production instead of having periodical releases. So software is also moving very, very fast. And enough, or unfortunately enough, I would say, the operations side of operating this infrastructure, operating this software has not accelerated as much. We're still using techniques or methodologies that were developed 20 years ago. As part of the ITIL framework, we have the CMDB, the configuration management database. We also have change management processes. These are two very useful processes, to be honest. I think they revolutionized how we operate environments just 15 years ago. But as we look at this trend of rapid acceleration by a few orders of magnitude, these paradigms are not working anymore and are creating some serious challenges for operations teams. So let's dive into each one of them. We'll start with by talking a little bit about root cause analysis, and we'll see how that ties into change management. So I don't think anyone who's in our audience needs me to repeat this, but root cause analysis is probably the most significant thing that you should focus on if you want to reduce time to resolution for incidents that you have, right? For short-lived incidents, it's true that maybe most of the time of your operations teams is spent around triage and remediation. This is why you need to invest in tools like event management. But as you have longer lasting incidents that last a few good hours or maybe even days, the majority of time is actually spent around root cause analysis. So if we know that root cause analysis is the main component for long-term incidents, we also know that to drive mean time to resolution down, we need to take this root cause analysis component and make it shorter. How did we tackle this 10 years ago? Well, the main way was to understand what has failed in our hardware infrastructure. The reason for that is that most of our outages, most of the issues we experienced in production was a result of some issue in our hardware stack. You know, everyone here on the call probably remembers power outages, corrupt disks, network issues, many kinds of issues that are related to hardware. You know, I remember from 15 years ago going through the data center with a Fluke network monitor, trying to understand what wire is not connected correctly or what router or switch is failing at the moment. And I'm sure everyone on the call remembers these kinds of activities related to hardware failures. And what would be our approach 15 years ago, 10 years ago, to understand quickly what is the offending piece of hardware? It would be to adapt good coverage around monitoring and around logging. If we have monitoring for our storage, if we have monitoring for our networks, if I have monitoring for our servers, for different devices in our networks, it becomes easier and easier to understand quickly what is the root cause of an issue. Right, so we essentially the last 10 years, we've seen many enterprises buy any kind of monitoring tool that they could, trying to make sure they have visibility across their stack for any blind spot they might have in their hardware stack, using monitoring and of course aggregating logging, using log aggregation platforms to be able to sift through logs very quickly. Another example, by the way, I can give you from my own past. I remember sifting through SNMP logs, trying to find some failed storage disks, trying to understand which disk failed. And I'm sure many people here would be, this is an experience that would be familiar for many people. You know, this has been very important 10 years ago. I think it's almost unimportant at all these days. And the main issue is that the outages, the issues have moved up the stack, right, towards our applications and databases and our users, of course. And frankly, the hardware issues are now being abstracted away. If it's off-prem infrastructure, if it's cloud infrastructure, this has been delegated to the cloud operator. So today, if I have a network issue in my Azure or Google or Cisco or Amazon environments, I don't really care about that too much because that is something that is being managed by the respective teams in these organizations. If I have on-premise infrastructure and I still have my own storage grids and my own network equipment, even that is being abstracted away because a lot of the hardware today has built-in redundancy and failover, meaning that if a single piece of hardware has failed, I still have enough redundancy to avoid any major business outage. So my operations team does not treat that as a major issue at that point. So hardware used to be a very important piece of our root cause analysis strategy, but today it's becoming less and less important. And you might ask yourself, if we're saying that root cause analysis is so important for driving mean time to resolution down, but we're also saying that hardware is no longer the source of or the main root causes of issues, what is the main causes of issues? And this is where change management and change and thinking about changes becomes so important. So let's look at this diagram that we have right here. What do we see in each one of those charts is essentially the number of changes in each day over a few weeks, right? On the left side, you see that once a week, more or less, we have a lot of changes, around 100 changes for that day. And then in between those days, we'll have a few changes, mostly for hot fixes or urgent changes that we had to do in between the change days that we have. And many enterprises operated this way. Essentially, you had a change approval committee. You had change windows. Every change would have to go through these pre-approved changes. Changes were normally part of major version updates. So one of your services would go from version 7 to version 8. You'll have a major deployment that would happen on some Tuesday, once a quarter, and that would drive changes. Now, if you look at modern environments, now if your different teams in your organization are now adapting continuous delivery, they're pushing code to production hundreds of times a day, right? In this chart, we have on peak days, we have around 300 changes. In reality, many of the enterprises we work with say some teams even push code 1,000 times a day into production. So the pace of change is really radically different than what it used to be 10 years ago due to this adoption of cloud continuous delivery. And to that, the fact that teams are now more distributed, right? The whole adoption of DevOps methodologies also means that now teams are able to make changes in their environments without kind of skipping the centralization of visibility around changes. So this is what I often call shadow changes. You have a centralized operations team, maybe a NOC, a level 1 organization, or a SOC, and this organization has no visibility around changes that are occurring throughout their enterprise because individual teams are now conducting changes without creating that centralized visibility to the main NOC, to the main organization. So that's why it's often helpful to think about those as shadow changes. They happen, but they happen in the shadows when it comes to the perspective of the L1 team. Now, when it comes to infrastructure, of course, we used to have very static infrastructure. 3 months ahead of deployment, you would get the servers ordered from the vendor, integrated into the rack, operating system installed, configure the server as needed, and then 3 months later, you might have a server in place with your application running of that, providing some kind of business service. Today, you can scale 17 new servers with a click of a button, or you can run something in the command line, and essentially you have these new servers ready to go in production, and end users actually using software running on those servers, again, within seconds. We also have autonomous changes as well, meaning that essentially humans are not part of the orchestration of new servers in our container environment or cloud environment. We have things like auto-scaling. Essentially, we have a high user load on our system. The system automatically provisions new servers without anyone even triggering the action. The end result of all of these activities that I just mentioned is that the pace of change has gone up drastically. I think this picture is very important. And the one reason is that I think everyone understands that the pace of change has went up. What not everyone understands, however, is how much it went up, right? And what I've seen people do in various enterprises actually create a version of this, what you see right here, for their enterprise. So they'll plug into their ServiceNow Remedy change management system. They'll go back in time, 7 years back in time, collect all the changes they had back then, create kind of this histogram kind of chart to show how many changes they had each day. They plug into their existing continuous delivery platforms, their change management platforms, their various auditing tools, and collect the amount of changes that are happening today. And they'll show the before and after picture. And I think this is very important in kind of creating awareness throughout your organization about how much the pace of change has went up. I don't think many executives realize how much up it went. It's not just an incremental change. It's a couple of orders of magnitude in terms of the increase in the pace of change. Now, the reason this is important for the context of root cause analysis is that we know that changes are the main cause these days of incidents, right? If it used to be hardware that failed 10 years ago, and we said that incidents moved up the stack, what is causing incidents to happen right now? It's changes in your environment. And this is based on our customer base. We asked our customers, what % of your incidents are caused by changes? You know, quite a few customers said it's 90%. So 9 out of 10 incidents are caused by changes. Some say it's a little bit less, 60%. But no matter where you are in this range, it's clear that the main thing that is causing outages today for you are changes in your environment. So if we know that we have a couple of orders of magnitude more changes than ever before, and we know that changes are causing incidents, you know, it's pretty clear, I think, it's very apparent here that your strategy has to revolve around changes, right? You need to focus on changes. If you want to improve your root cause analysis, you need to start identifying the changes that are causing your incidents to occur. And that has to be your focus for RCA and, of course, driving MTTR down as well. So let's try to articulate a strategy for modern environments where it comes to root cause analysis. I just said, focus on changes, data for RCA. Stop focusing your energy on more monitoring tools, more visibility across the stack that used to be helpful 10 years ago. It's not the key. Today, the key is understanding change data sets. Secondly, there's one single silver bullet to understanding what are your change sources, right? Change management used to be your main source of data. Today, there are multiple change feeds throughout your stack. There's continuous integration tools like Jenkins or Bamboo or TeamCity or others. A lot of your change data is actually happening as part of that CI/CD pipeline. You might even collect those changes directly from your source control systems like GitLab or GitHub or any Git repository that you use. There's a lot of automated orchestration today with tools like Chef, Puppet, Ansible, Terraform, Kubernetes. Use those sources as feeds for what is changing in your environment. And of course, today we have a lot of good auditing tools, especially in the cloud environment, to understand what changed in my cloud environment. For example, the best known one is CloudTrail from Amazon. If you connect to CloudTrail, you'll essentially see any single change that occurred in your cloud environment in a lot of details. You can see exactly who did what, where, how, when, and that information can be very helpful to create change visibility. Now, once you have collected all these changes, it's not enough to know that they occurred. You need to actually provide very easy visibility to your operations team, to your NOCs, to your L1 organizations, to even to your L2 and L3 organizations, and your DevOps teams. You want to create visibility around what has changed. So make sure that all these changes are collected and indexed. They're easily searchable, and the operations team can actually look through those changes on a daily basis whenever they have an outage. I can tell you an anecdote of I spoke to a large insurance company recently, and the story they told me around changes was essentially that they print out, they have an Excel spreadsheet with all the changes that are planned for the day, and they print out that spreadsheet, and they use that spreadsheet, they print it out and put it in the operations team next to each operator. Whenever there's an outage, the operator sifts through all these changes from the spreadsheet, trying to understand what might have changed at that point of time. Now, obviously, this is not very efficient or scalable, but more importantly, it's not up to date. A lot of your changes will not be in that spreadsheet. Your changes would be in all of the sources you see right here, and trying to sift through, printed out records, that's not the best way to identify what is the actual root cause. And this is where I actually recommend you to go one step further, not just create visibility, but actually create automation, actually leverage AI technology to understand what change is the likely cause of an incident. So let's say I have some kind of application issue, maybe high latency, maybe some transaction errors. I want to understand what has changed that might have caused this. This can be any change in some database configuration, some message bus has changed, some servers were orchestrated, maybe somebody deployed some code into microservice. If an AI can actually make that connection for you, or the operator, and tell them, this incident has probably occurred because of specific change that we had tracked here, this is a game changer in your ability to do root cause analysis and drive mean time to resolution down. This can cut a 4-hour outage down to a 5-minute outage if you have this technology in place. So this is regarding root cause analysis. Let's move on a little bit to topology and kind of dependency mapping. So again, I think anyone on this call will understand very intuitively why topology modeling is so important for the world of IT operations. 2 main reasons: impact analysis and root cause analysis. If we have maps between our different infrastructure elements and the services that run on top of them, then once we have some kind of issue in the underlying infrastructure, we can immediately understand the impact of that by tracking that back or backtracking that up to the affected service, right? For example, in the diagram we have here on the right, if we have some issue on this physical server, we can track that back into the application at the top. This is impact analysis. And dependency mapping is actually a little bit in reverse, where we say, let's say we have 10 VMs running on some physical server. All these 10 VMs are complaining about some kind of load issues they are experiencing right now. If we understand the dependency between the virtual machines and the physical machines, then we can quickly understand that there's one underlying physical server experiencing issues or slowness or load issues, and that is probably what is creating the load on the individual VMs. So obviously, topology is extremely important if you want to support these 2 critical operational workflows: impact analysis and root cause analysis. How did we approach that 10 years ago? Very simple answer. We all know this. It was the configuration management database, the CMDB, essentially a database of all the assets and all the relationship between these assets in our environment. The CMDBs were amazing. Most of our customers still have a CMDB in place. It's essentially a single source of truth around your entire topology, whatever you have in your environment. How would you populate such a CMDB? One of 2 methods, sometimes a hybrid approach. One would be manual data entry. You would have a team of people actually adding records to the CMDB whenever somebody is deploying a new application or somebody is changing some configuration. They would enter that data into the database, and that way try to keep it up to date. And then there was auto-discovery technologies, which still some companies use in some environments, where essentially you run a job once a day, once a week, once a month, and that job will try to scan your network and figure out the different dependencies in your network. Challenge with auto-discovery tools was always that today the tech stack is so fragmented. There's so many different technologies that you might buy an auto-discovery tool to cover one piece of your stack, but it will not give you good results in another type of infrastructure. For example, you might have auto-discovery tools to discover network dependencies between your Cisco switches and your different devices, but then it will do a very poor job understanding the topology of your Java applications and .NET applications, and of course, Python applications, Ruby applications, which are even more complex and more modern. But in any case, many enterprises were able to build a decent database, getting to 70–80% coverage throughout their stack using this CMDB. But this whole radical shift in the pace of change means that even if you have a decent CMDB right now, it's not going to be operational or working effectively for you in 2–3 years. And let me explain why. Essentially, your topology is changing today faster than your CMDB, right? Your cloud servers are being provisioned within minutes. Containers are orchestrated with Kubernetes or other technologies within seconds. Your CMDB is being updated maybe once a day, once a week with auto-discovery tools with manual data entry. They just cannot catch up with the pace of change of your actual infrastructure. And one example I like to give here, one metaphor that I think helps explain this, that I think is very clear, is around maps and geography, right? Let's assume you're driving to a new destination and you're using some kind of navigation app like Google Maps or maybe Waze or some other navigation application. And it does a perfect job of leading you, throughout the roads to your destination of choice. Now, imagine a world in which the geography itself is changing faster than the maps within these navigation maps use. So navigation apps used. So essentially, let's say roads are moving in real time, cities are moving in real time, and you're trying to navigate to a destination using a map that was created a week ago or a month ago. Obviously, this will never get you to your destination. So similarly, CMDB is essentially a map to our IT environment. It's a map to our data center. But if our data center and our IT environment is moving faster than that map, then that map is not really useful for navigating our IT environment. Let's talk a little bit about a strategy to how you can still tackle the problem of topology for the world of modern infrastructure. One, I think this is the hardest part for many enterprises, is just accepting there is no longer one silver bullet for topology information. Like CMDB can be a nice source for some use cases. It will not provide 100% coverage for your entire infrastructure. I've spoken to a large retailer who's a customer of ours. They have a CMDB that they love, absolutely love, that covers their store infrastructure. So their in-store infrastructure is represented really well in their CMDB because that's slow moving. But anything that is part of their e-commerce activity in their private cloud, in their public cloud, in their container infrastructure, that is not represented in their CMDB. So for these data sources, for these parts of the environment, you have to use other sources of information for topology. So my recommendation is try to stitch together a topology model. Essentially, you use different data sources to understand what's your topology, and stitch together, you can actually create a pretty accurate, up-to-date model of your infrastructure. And thankfully today, as part of the acceleration of IT, we have these great sources of truth about the infrastructure, about the topology of our infrastructure. We have configuration management tools, right? Everyone uses some sort of a Chef, a Puppet, an Ansible that can help you understand what software is running on what servers. You might have some orchestration tools like Kubernetes or Terraform that will tell you what are the different regions, availability zones, what are the different clusters that you have for different servers. If you use something like a service discovery tool, maybe use something like a Zookeeper or an etcd or a console from HashiCorp, these provide terrific visibility around the dependencies between different microservices in your environment. That's another very useful source, assuming you use any of these technologies. Then many of us have APM, application performance monitoring tools, the New Relics of the world, the Datadogs, the AppDs, the Dynatraces. What they essentially do, they trace your transactions, your application transactions, and they have some great information about what applications are running on what servers and what databases are connected to those applications. That's another great source for some part of your stack. And of course, your traditional good old CMDB might provide some visibility to some environments. If you stitch together, piece together all of these different sources, you can get a very nice looking topology model. If you rely on any one of those, just one of those, you'll have to face a reality in which you only have visibility around 20 or 30% of your infrastructure. And lastly, and I think most importantly, the maps needs to adapt in real time to the geography, right? So you have to make sure this topology model is being updated in real time. So you have to plug into those resources, and whenever they change, at least within minutes, in the maximum, you have to update the topology model as well. The real-time component is very important if you are now adapting clouds and container technologies or serverless technologies and microservices and continuous delivery. You got to make sure that you have the real-time component for your topology modeling, which will then drive, as we have discussed, will drive both impact analysis and root cause analysis based on this dependency model. To summarize a little bit what we discussed, again, acceleration of IT, biggest, most important trend for IT operations organizations in the last 10 years. How it's been manifested in infrastructure, clouds and containers, how it's been manifested in software, microservices and continuous delivery. What it means for operations teams, it means that the good old strategies from 10 years ago, 20 years ago, unfortunately, they will not answer your needs if you want to keep your applications up and running, to provide the quality of service that your customers expect. These old strategies, CMDB, change management, they're not going to answer the requirements of your business. And you have to think about new strategies like the ones I described today. And by the way, BigPanda is planning to announce a couple of features in this space, so stay tuned in the next few weeks. And you'll see some good capabilities, out-of-the-box capabilities that we're going to provide to address many of the pains we discussed today. That's it with my part. Thank you, and Colleen, take it from here.
Thanks so much, Nancy and Elik. It's now time for our Q&A session. As a reminder, simply type in your question on your screen, and we will get to as many as we can. The first question for today is, what's your recommendation for what to do with our CMDB moving forward?
Yeah, I can take this. This is a great question. So, I would say this. I have yet to see a CMDB that's useless, right? The CMDB always has good information in it. The challenge with the CMDB is that it's not real time. It doesn't have good coverage across your entire stack, and sometimes it contains inaccuracies. That being said, in the same time, CMDB is probably the best source of data you have right now when you try to think about your topology. What I suggest is don't retire your CMDB. Don't even plan on retiring your CMDB in the next 5 years or so at least. See how you can have that CMDB integrated into a bigger project. You should have a real-time topology project in your organization, as we discussed, that pieces together a topology view from different sources. Your CMDB should be one of the main sources feeding into that federated CMDB, or federated topology model that you're creating. Some customers might ask, hey, can we turn our CMDB into this federated CMDB model with our real-time topology? Unfortunately, the answer would probably be no, based on what we've seen in the market. The reason for that is the traditional CMDB platforms were not designed for rapidly changing infrastructure. So if you try to connect your chef information directly into your CMDB, your chef will move so fast, but your CMDB records will not be able to be refreshed at scale at the same pace of change. So what we essentially say is take your information from your CMDB, but feed that into an external database that is designed for real-time topology modeling.
Yeah, and I'll just add, I mean, that's pretty much in line, with what I'm saying. And I think you sort of alluded to this earlier, Elik, but one thing I've heard people do is they keep their CMDB because, like you said, it's useful, but they might limit its scope. So, they won't even, there's sort of no sense in tying your more modern and, frequently changing environments to it. So people will use their CMDB to track, employee workstations and maybe, servers and other data center equipment in a data center that is relatively static, right? That supports maybe a legacy application that's not changing a lot. And then rely on these, other tools for other kinds of, change management that they need, in a more cloud-native environment. And I also just wanted to acknowledge that I think this is a kind of a tricky question in some organizations because, CMDBs are typically a pretty big investment. A lot of people, probably go into the decision to invest in a CMDB. It's not easy to just get rid of it, right? So I think it's, looking for ways that it can be useful is probably a good approach.
The next question is for Elik. What is the minimum amount of CMDB data that's required for BigPanda to present a map?
Yeah, great question. The answer is 0. You don't have, many of our customers don't even have a CMDB, to be honest. I think part of the point I made around realizing that there is no longer one silver bullet or one source of truth for topology data. There are downsides for that because now you need to plug into multiple sources, but the biggest upside of that is that you no longer depend on just one source. So if you don't have a CMDB, or you don't have service discovery, or you don't have a configuration management tool, that's okay, because there is enough information out there in your infrastructure, in your environment, to collect that topology information from other sources to piece together a very meaningful topology map. So we have customers that just don't have a CMDB at all and still get a lot of value. We derive, the main use case we derive with topology information is correlation. And some of our customers that don't have a CMDB get to 99% compression in terms of their correlation rates without a CMDB.
Great, thank you. Next question. Do you have any tips for driving some of the change you talked about today? We have some of the problems you discussed, but I'm not sure management recognizes that we need to solve them.
I'll take that quickly. one thing that I would recommend is start measuring if you're not. So I think that it's important to be able to prove what you're trying to show, management. So if you can show that it's taking you a very long time to respond to incidents, that's going to help your case. So, usually the monitoring tools that you already have, the incident management tools that you have, can be used to measure the way that you respond to performance incidents. And I think that kind of measurement can help you make the case for needed improvements, and then they can also help you prove that those improvements were worth it, right? So if you can compare before and after, that can help, prove that your changes were worth it. So I think that's something that I found really helpful in organizations that are looking to try to make the case for making these kinds of improvements. Elik, I don't know, do you have anything to add there?
Yeah, just maybe one quick tip is that I've seen many IT executives focus a little bit on the solution part when they try to advocate these changes, when they make a case to their CIO or CFO or COO. They focus on, hey, we need to get this topology map, right? We need to get some solution around change visibility, for example. But I would suggest actually start with the pain, start with the problem, make sure that there's consensus around your organization, that the pace of change has moved up, that it's moved up by an order of magnitude at least, not by some kind of incremental amount. And then also make the case that this pace of change, radical change in pace of change, is resulting in a lot of pain in different parts of your environment. And then talk about the different kinds of pain around change visibility, around topology visibility. Once you have consensus, I've seen it's pretty easy to get to consensus around the fact that these workflows are broken and that they are important and that they have to be addressed. Once you have that consensus, it becomes much easier to actually make the case for a specific solution in this space.
Great. Thank you so much to both of our speakers today. That concludes today's webcast. As a reminder, the on-demand replay will be available on On24 soon. On behalf of BigPanda and 451 Research, thank you so much for attending and have a great day.